This is my lab 3.5 ocean acidification experiment. So basically, I have boiled the cabbage, and I have about that much that I boiled. When you boil the cabbage, it basically turns it into a pH indicator. So I'm going to pour them each into, I have a bunch of different cups with labels on them. I'm going to be using ammonia, vinegar, lemon juice, soda, and I chose Sprite for that, baking soda, and then tap water. And then we'll see the acidity level of each one. So that's how much I'm pouring. Okay, so we're going to go ahead and start with tap water. So when you pour, we're going to actually take some water, and this is purified water, and we're going to pour it in a half a cup in to dilute it. And then we're going to take just a little bit of our tap water, and you'll notice the change in color. It's turning to a little bit more of a blue color, and we'll see what that looks like. Next, we're going to add baking soda. That's what it looks like right now. It's a little bit of a different color. It's not as purplish as this one. It's more of a blue tint. And then I'm going to add half a cup of the purified water just to dilute it. And then I'm going to take a teaspoon of baking soda, and then you'll notice it turns very blue. It's more like a blue color. And this is a base, and it has a pH level of 9. So the next we have our Sprite. So we're going to go ahead and do half a cup of water, just to dilute it again. And then we're going to do a teaspoon. Just a little bit. Oops. And you'll notice it turned a pink color. And that's because it is acidic, and it has a pH of around 3.3. So the lower the number, the more acidity that it has, and then the higher number, it's a base. So the next, we have lemon juice. So again, we're going to pour water in there. And then we're going to squeeze some lemon juice. And you'll notice that this one's a little bit different colored pink than this one. It's more of a brighter pink, which means it's more acidic. And this one has a pH level of 2.2. It's just 2. And then our next one is going to be vinegar. We're going to take our water. Pour that in there. And then we're going to take, I have white vinegar. It should still work, but I just used that one. And same thing, it's going to turn a pink color. So it's kind of in between. This is a darker pink, and then there's this pink, and then there's our lemon juice. So then lastly, we have our ammonia. Oh, and then our vinegar has a pH around 2.2, so close to that lemon juice and close to the soda. So then we're going to pour the ammonia in there. And you'll notice that it's a green color. It's a little bit different. And then ammonia has a strong base, and that is going to be a pH of 11.6. So as you can see, we have all these different acidities. So basically, purple is going to be the neutral color. That's going to be like around your water. However, with tap water, it has different minerals in the water, so it turns the purple color. But this is a blue tint. It's not our original color. This was our original purple. And then we move down and we get like a purplish pink color. This one's like a mild acid. And this one's our soda. And then we also have our lighter pinks, which is our lemon juice and our vinegar. And that's going to be a stronger acid. Then we move to blue, and that's our normal base, and then to green, which is our stronger base. Awesome. So then for our second part of our experiment, we're going to test two different ones. So I have my straw, and then I have 2 cups that I previously poured. And this one we're just going to leave alone just to see the difference. And then I'm going to blow into the cup and make bubbles. And as we add the carbon dioxide to the air in this, basically it's just going to turn a different color. So as we add carbon dioxide to the air, it's mixing with the ocean. And it forms what's called carbonic acid, and as we add carbon dioxide to the ocean, it becomes more acidic, just like all of these over here, which is really hard on that sea life, but noted. So you can see it's already changing colors. So look, it's getting lighter. So as you can see, there's a difference right there. I only did it for about a minute, but if you continue to do it, it becomes more acidic, which means it's going to become a lighter color. It could possibly even turn even more pink, and that's because we're adding that carbon dioxide into the pH indicator. So basically with the ocean acidification process, with the ocean, carbon dioxide releases burning fossil fuels and are making the world's oceans more acidic. The process includes, like, one, the carbon dioxide from the atmosphere is absorbed by the ocean, so it sucks it all in. The carbon dioxide that reacts with salt water to form carbonic acid, and salt water's pH is lowered. And then we go onto the third step, which is the hydrogen ions are released by carbonic acid to bind with carbonate and form bicarbonate. So it's a huge process. This is emitted by human activities. Marine organisms could experience changes in growth and development and abundance, even survival. This could also affect and cause loss of employment and other indirect economic costs. This includes the loss of food, coastal protection, tourism, and carbon storage, as well as climate regulation. With this whole ocean acidification, I am concerned about it. It's basically taking away a lot of our resources that we use. But as our marine ecosystems provide us with a large amount of goods and services that will be eliminated and taken away, and that includes, like, our seafood and natural products. But this problem only creates more problems, and then eventually we may be jeopardizing all of our hard-fought ocean conservation gains. But yeah, other than that, we saw all of what we learned about acidification. But hope you guys have a good rest of the year. I know this is our last lab, so see you guys.